All right, welcome back to FRQ Progress Mastery. No, sorry, Mastery Project. So basically, in a physics lab, a group of students are provided with a sphere of unknown mass, a roll string, a ring stand, and a measuring devices that are commonly found in a physics labs. The students must graphically determine the acceleration due to gravity near the Earth's surface by putting the sphere into simple harmonic motion. So part A asks us to state a physics principle, law, or equation that students can use to graphically determine the acceleration due to gravity near the Earth's surface by putting the sphere into a simple harmonic motion. So, number A, this is how it would look in real life. So I sketched it out. We have a piece of string with an unknown length. We have unknown mass. And we have different points. Now for part A, we know that the time it takes for something, a pendulum, is equal to 2 pi square root of L over G, right? Part B asks us to design a procedure that the students can use to graphically determine the acceleration due to gravity by putting the sphere into simple harmonic motion. Basically, it's just giving us a graph of what to do. Quantity to be measured. Well, the only variables we need would be a meter stick. The symbol for the quantity will be m for meters, and the equipment that we will use is a meter stick. Sorry, what we will be measuring is the length. We also need to measure the time it takes. So time, the time we will use is seconds, and what we will use is a stopwatch. And a procedure that we can use is we're going to hang up the ball on top of a piece of string, and we're just going to let it oscillate back and forth. Make sure that theta is no more than 10 degrees. So theta has to be less than 10 degrees. Very important. If it's not less than 10 degrees, it is not simple harmonic motion. Bum, bum, bum. Okay. So we're gonna let it go back and forth with different lengths of different string. Very important that it has to be multiple tries of the same as well. And remember, no more than 10. We will graph the time it'll take. Students must graph, indicate which quantities can be used on horizontal or vertical axis due to the acceleration near the Earth's surface using a best fit line. You may use the remaining columns. So here, all we really need to do is isolate. Okay, so now that we have that, we isolated G and we got 4L times pi squared is over T squared. So now we really kind of just look at there's only two variables right here. It's L and T, and we can write it as so, since it's already presented as L over T. So we just simply put L right here, the length of the string, over T squared, and there we have our graph, our amazing, beautiful graph. All right. So the next question. Students determine that the slope of the line is m. Derive an equation that can be used to determine the acceleration due to gravity near Earth's surface using the slope of the graph described plotted from C. Express your answers in terms of slope m and any fundamental constants. Oh, sorry, I got cut off a little. But essentially, if I can readjust my camera for a little bit. Essentially what is happening here is you have G, right? This is all going to be M. You have a constant that should be 4 pi. So basically, if we would have written it the other way, it would have to be g is equal to pi divided by m. But since we wrote it this way, these two switch to g is equal to 4 pi times m, right? Because you know it's inverse. One second while I find the final question. Okay, so yes, so we have the object right here, right? At point Z, we just cut it off, completely zip it off. Describe predict the motion of the sphere in the string in terms of the sphere's displacement, initial speed, and acceleration. Okay, so we know at this point it has the lowest acceleration. We know that it has the highest velocity, and we know that the only force after it's cut off that's making it go is the force of gravity, F of g. So once it cuts off, it's still gonna have a velocity, so it's gonna go down there, but it's gonna have a force of gravity, and these two forces will work together to make it go downwards in this direction. So it's gonna cut off and kind of fly off into a zone and boom, hit the floor.